channel. I'm here with a new topic about network analysis. In network analysis, I'm gonna discuss about the superposition theorem. Let's discuss the theorem afterwards the problem. Let's solve a problem on superposition theorem. The superposition theorem, this theorem is applied between and multi-source networks. The superposition theorem states that in any linear bilateral multi-source network, the response in any branch is equal to the algebra sum of the response obtained in any considering each source acting separately by making all other source set equal to 0. And the voltage source are made 0 by shift circulating the networks, and the current source is also 0 by open circuiting it. The proof considered by the network as shown. See, this is the proof. It's a circuit where we consider the network as shown as Z1, Z2 and Z3, where voltage is positive and negative. Let's consider I1, I2 and the downwards of Ix, and where here the current is flowing towards downwards. First, we should apply the KVL for the loop 1, where Z1 I1 plus Z2 into I1 minus I2 is equals to V. When we apply for this, the V, first we get the minus V. When the minus V goes to the either side, it becomes a plus. The Z1 plus Z2 into I1 minus I2 into Z2 is equals to V. But where I2 is equals to I, so Z1 plus Z2 I1 is equals to V plus I into Z2. So I1 is equals to V plus I Z2 by Z1 plus Z2. This is an equation 1. We know that where I2 is equals to I1 in the above condition, from the loop 2, we should consider the loop 2, where the Ix is flow, they are shown in the Ix, where the Ix is equals to I1 minus I2, because it is in the position of Z2, right? So I1 minus I2 when we are applying KVL, where V plus IZ2 by Z1 plus Z2 minus I. For the above equation, where when we take the LCM, where Z1 plus Z2 becomes an LCM, where Z1 plus Z2 into I minus Z1 into I minus Z2 into, where Z2I get cancelled, remain of V minus Z1I by Z1 plus Z2, where it is considered as Ix. We have founded I1 and the Ix value from the equation 2. After that, the verification of the equation 2 by the superposition theorem. To apply the superposition theorem, consider the one source at a time. The first case, consider the voltage source and set the current source at 0. Okay, we should consider some, and we should set as 0, where voltage, and we are open circuiting here, where I1 is equals to V by Z1 plus Z2. After that, the case 2, consider the current source and make the voltage source as 0. We should consider the current source here, and we should make the voltage source as 0. Using the current division rule, we should use the current division rule in the superposition theorem, where the voltage source we are converting into the 0. So I double dash, already we have got I1. The I double dash is equals to Z1 by Z1 plus Z2 into minus I. After that, the superposition actual current, where Ix is equals to I dash plus I double dash. So V by Z1 plus Z2 minus Z1 I by Z1 plus I2. This, where Ix is equals to V minus Z1 I by Z1 plus Z2. This is the equation 3. After finding this, then the superposition theorem has been proved. After proving the superposition theorem, let's discuss the problem on the superposition theorem. Let's understand how to use the superposition theorem to analyze the circuits with the help of an example. I am going to take an example which have been solved, the problem on superposition theorem. The example 1, what I have been explaining, the problem on the superposition theorem. Find the current flowing through 20 ohm using the superposition theorem. Let's see the circuit, where here the current is 4 amp and the 4 resistance 5 ohm, 10 ohm and the 10 ohm and 20 ohm. The another one is where the voltage source is 20 volts. To find the current flowing through the 20 ohm using the superposition theorem. This is an question and this is a diagram. For the first step for the finding the current. First let's see, we should remove the current source there. Let us find the current flowing through the circuit by considering only the 20 volt voltage source. The current source can be open circuited, hence it modified the circuit diagram as shown in where we leave this current source, the 4 ohm it is there. The 20 volts we have taken, the 5, 10, 10 and the 20. We should solve by the node voltage. The V1 can be determined using the nodal analysis method also. The equation as the node 1 is taken as V1 minus, we can apply the I1, I mean the KVL rule also we can apply by the nodal analysis also. V1 minus 20 minus 20 by 5 plus V1 by 10 plus V1 by 10 plus 20 is equals to 0. This is by the nodal. After we will get the I10 V1 is equals to 120, where V1 is equals to 12 volts. The current flowing through the 20 ohm resistor can be found using the following equations, where I1 is equals to V1 by 10 plus 20, where I1 we will get 0.4. Therefore, the current flowing through the 20 ohm resistor due to the 20 volt voltage source is 0.4 amp. After the step 3 is, now let us find out the current flowing through the 20 ohm resistor. Considering only the 4 current source, we eliminate the 20 volt voltage source by short circuiting the modified circuit. Therefore, it is given as follows. See, after short circuiting the 20 voltage source here, again we will add on the 4 ohm current source here. We have short circuit in the the left side part. In the above circuit we have short circuit in this, right? The resistor of 5 ohm and the 10 ohm are parallel to each other. The parallel combination of the resistor in series with a 10 ohm resistor. Therefore, the equivalent resistors can be, what we have formula, that is when it is parallel, where R1 into R2 divided by R1 plus R2, either you take any as an R1 or AB, or they have taken as AB, where A into B by RA into RB by RA plus RB. RAB is equals to 5 into 10 by 5 plus 10 is equals to 40 by 3. Now the simplified circuit is as shown as follow. And the fourth step is a summation of the current of I1 and I2 will given as the current flowing through the 20 ohm resistor. Mathematically it is represented as follow, where I is equals to I1 plus I2. Substituting the values of I1 and I2 in the above equation, we will get an I value, where the first equation was 0.4 and the another was 1.6. We got 2 amp. Therefore, the current flowing through the resistor is 2 amp. This is about the problem what have been solved and explained in this about the superposition theorem. It is easy, and thank you guys. Please like, share and subscribe.